Alright, YouTube family, part number 3 of the Marvel Schebler carburetor repair. So, in this episode, we are going to be creating a new brass fitting. Now, the reason for this, in case you haven't watched the other two videos, is we want to make this purposely longer, and the reason for that is because of where this is broke, how far back, we want to be able to reach back further into unbroken material. So yes, it's a taper, 1/8" pipe. I know everyone's like, hey, why don't you just use a thread die or a pipe thread. I've got that. I've actually got one for it. But because it's such an aggressive, and I'm going longer than what should normally be there, because normally you only need to go that far, okay? Because I'm creating a repair part, and the reason for this is past experience. Again, I was showed this trick years ago when I was a kid by an old machinist who would repair things like this. He said, hey, look, if you make it to where it's longer and goes back, then it's less likely to fracture out the repaired area. So we're trying to give this every fighting chance to not leak or break, which we've went through, we've cleaned out, we've pulled out, we've removed all the area where the crack was, all that's gone. So I've had some people already comment and ask in the other videos about putting Teflon tape on threads gets into the carburetor. You were putting it on wrong. Okay, if you put Teflon tape on correctly, it should be on the threads. Now I see guys do this, I've ran across it before too. If you get it, and I'll use my little pointer here, if you get Teflon tape, it's meant to be on the threads. No, it's not a lubricant. We're going to use the actual version of tape. Now, a little will work. The reason we're using it is because we're going to be having new threads on the new part and old threads on the old part. And there's a bit of a difference, you know. So, if you get Teflon tape down here and you get sloppy, and you get too much, yes, it's going to get cut off and it's going to go into whatever, the carburetor, wherever. So if you're getting to the, you know, I'm not going to use the liquid stuff on here because I don't want it to ooze away. Now if we're just doing water or a coolant, that'd be fine, but gasoline's involved, and I use the term Teflon tape. That's the most common thing that's out there. If you desire to use another thread sealer, that's fine. Another question was brought up about creating a nylon washer to go on here. Now, they are correct. There should be one that should go on here. Now, when I create this new part, I don't know if the individual, if Gene has the kit for this already. So, comment, Gene, let me know if you do have a washer, because there should be a fiber or nylon washer that goes between this and the carburetor. If not, if you don't have one, Gene, hit me up, let me know, and I'll make one. I mean, yes, there should be one in there because we want to seal two areas. Number one, we want to not only seal these old and new threads, but we also want to create a little bit of a seal with the face of, and we may even go up, and when we get done, I will actually set this up in the mill and I will true off the face of this because it still has a rough cast there. This was never like machined, smooth, flat, true, and we are going to do that. That's going to be something is after we get the whole, again, there's a lot of work involved in this, but yes, we are going to true that face up with the bore. And we're going to create a nice flush flat. So yes, there in theory should be some sort of a fiber or nylon washer in there. We're going to create that, or if he's already got one, but we're going to give it every fighting, because it should be a smooth face like that right there. Okay, we're going to give this every fighting chance to correct, you know, obviously they didn't make it that way back then, but we're going to improve it. So there's a method to the madness on this whole process, and I'm always open to suggestions, by all means. I'm open to, hey, what did you think about, you know. So what we're going to do, I've got the 5C on here. You guys hear some noise in the background, guys. We're pushing the high 80s here in New Mexico. Part of my garage is insulated, part is not. So if I don't have a fan or an air conditioner running, it can easily get to, I've measured it before I had the fan and the air conditioner, it'll get to 130 degrees in here. So I've tried to get the camera to where you don't hear the from the fans, but just know that's what the extra noise is. So I do try to take that into consideration. I did a little test shot, and the camera in this location did not prove to have any. If there is, I'm sorry, I apologize. So we've got the 5C collet chuck in here. I'm a big fan of it. We've got some 5/8 brass. We're going to go ahead and make sure we're tight in there, and that's the one that tightens the collet. It pulls it back in. So we've got some stick out here. Our overall part we're going to create here is going to be a little bit longer than the original. Okay, the original part overall length is approximately 900 thou. Okay, this is going to be an inch. Well, we measured the depth, which was 1 3/8 inches. So we're actually going to make, I'll turn it around this way. This is the end we're going to make longer, which is the 1/8 inch pipe thread. And I want to make it about 1/4 inch longer than what it is. So this is just kind of some eyeball measurement. Okay, that looks good. So we'll come in here this far, and we'll just call that our stopping point for threads. Okay. Go ahead and back up a little bit here and get started using our positive raked insert. Now we've went ahead and already lined up off of camera our threading tool. We've got it set up so we are 90 degrees, because our threading tool that we're going to be using is for really small threads. I don't know if you can see that, which is what we're going to be cutting. So we already did that ahead of time, so the videos go quicker. You guys know me, I try to get stuff, because I don't edit, so I try to get as much done ahead as possible. So here we go. I'm just going to go ahead and make a witness mark here, and then we'll go ahead and we'll start boring it out before we do all this other stuff. Actually, what I'm going to do, I'm going to call that my 0 point. Okay. And we'll call that 0. Now, what I'm going to do, let me go ahead and explain this real quick. I'm going to just have 2 flats on this. Okay, I'm not going to go in and create all 6 flats. We don't need to, because this is just going to be a one-off part. Keep it simple. We're not going to be taking the part in and out, in and out, in and out. So essentially, you will be able to get on there with a crescent wrench, you know, and we'll come in, we'll make it this diameter here, which is should be 1/2 inch, I believe. Yeah, so we're going to make this 2 flats that will end up being 1/2 inch, but we're going to make our major diameter, so we have plenty of room to work here, is going to be 570 thou. We're 625, so we've got a ways to go. 0. we've got our 0 set. I want the major diameter all the way down, but I've got my 0 mark up here. That's going to be for the first side. We'll take the total major diameter all the way down. We're going to go ahead and work the major diameter down first. Let's see where we're at here. So we're 566, and we said we want to take the major diameter down to 570. That's not a showstopper. Couple thou under. That's just so we left ourselves enough room to go down and make our flats. So we're good. That's fine. We've got everything off. Now we want to go back to our 0, and we're going to start working on the small side first. We'll go ahead and take it down, and the major diameter that we want to work down to for, we'll call it the small side of the fitting, and everybody has their kind of own method of doing this. I'm measuring at the back, which is going to be the large end, so we're going to call it 400 thou. Okay, 399, 400. Well, I've learned in the past, because brass turns down so quick when you go to do a finish with a file, you can get small real quick. So we're going to go down to 400 thou. We're currently at, let's see where we're at here, so we get it right in our brain. We are at 566, so we have 160,000 to take off. We'll take off 100 thou. Yeah. All right. And we're only going to come into our 0 point that we have set over here. Which is about a ½ inch in. Okay. Now I've learned not to get too aggressive on doing these small parts in brass, because you can break things really quick. You get too carried away trying to take off too much at once. And this insert does a really good job in brass. I've used it before, been really pleased with it. And I'll try to get you guys in closer here. So we are 444 thou. So we're going to go ahead and take, we want to go down to 400 thou. We got 44, so let's take, I'm going to sneak up on it just because of tool pressure and flex. Go ahead and dial in 10. I just have a habit of wanting to double check myself, because so many times I've scrapped out parts when I got down close and went under. So we're 426, so we got 26 thou. Let's take another 10. We're sneaking up on it. Sneaking up on it. It's 408, 409. So 409 thou. That's about where we're at. So we'll dial in 2.5. Just because. Do a spring pass. I have learned from previous experience, which equals several mistakes, which is how you learn. Leave it large, okay, on brass, because you can get undersized so quick it's not even funny. Just being up here, I noticed, you know, you bump dials and things, and you know, it's better just to leave a little bit to where you can work it off by hand. So we've got 3 thou, yeah, 3 thousandths. So what I'm going to do at that point, because I know 3 thou will come off like this. Let me go ahead and grab my file here. I know I'm going to be leaving, probably even leaving it a little large for the threads, which is fine. I just don't want to get undersized. So 402, just a little bit. I have learned my lesson the hard way so many times, thinking, yeah, I'll just dial in out on the lathe, and then you realize there's a little backlash or something, and then next thing you know, you're like way undersized and you've already had a lot of work into it. So, sneaking up on it, 4025. Now see up front here, we're a little, and that's what I was talking about, which is fine. 397, 396 when you look at the tip, but this is going to be way back in there, 394, which is fine, because if you come down here and measure this at the very end down here, and this is what I was talking about, if you come down here and measure the last couple of threads, okay, because of how it tapers, let me get it in here and I'll show you guys on camera what I'm talking about, which is fine, okay. I'll measure the last couple of threads. We're actually 380 thou, so that's not a showstopper. I've learned doing this, you have a method to the madness to work your threads down to the size. Now, what I am going to do, because I'm not going to cut the back side of this yet, okay, that's going to be when I flop it. So we're done with this for right now. We'll go take that tool out, and that set that there. What I'm going to do next is I'm going to come up here and do my through hole, which the through hole that'll work for this is going to be a 15/64. We're going to go all the way through, and then when we flip it on the back side, we've got to take it out to a 5/16 ID there. And if we have to adjust, I purposely used smaller bits because we all know drill bits do not cut round holes. If you want it round, you go in with a reamer or other such item. I'm trying to show you guys over my left shoulder so you get a good view of what's going on. And I will zoom in a little bit so you guys get a little machining action here. If I can get everything loose. Ah, that got tight. Okay. Actually, first I need to get my, sitting here talking and got sidetracked, I need to get my starter bit first. See, that's where you get sidetracked, is trying to shoot video and talk. It can happen so easily, you get messed up. Alright. You really got to concentrate. don't need any lube because it's brass and it's really soft.
That is all the way through on that side. Come in here, get a little blast of air. I'll try not to bump the tripod. And of course it's bumping the tripod. And it's what happens when you try to get everything too close together. You're always bumping things. Sorry about that. Okay, so we're in, we're clean, and I'm going to come in here with the chamfer tool real quick. One of my favorite ones I use for a lot of things here. Just a real quick, light, break the inside edge. Nothing's fitting in from this side, but we're just going to go ahead and break that edge on there, make sure everything's good. Alright. That's done, that's done. Now we're going to come in here with our threading tool. Alright. Now I'm going to slow everything way down. Alright. Now, normally you would create a really deep thread relief on the back. If you'll notice on this fitting here, I'm trying to get the camera to where it'll focus on it, there is no real thread relief, so we're going to thread up against a shoulder, and we're going to get everything set up on 27 thread per inch. Let's see here. (26, 24). Interesting. I was just under the presumption that my lathe had 27 threads per inch. It does not. Interesting, interesting. It goes 20, 22, 24, 26, 28. Outstanding. Well, guess what? That is just so depressing. So, again, if it were easy, everybody would be doing it. So I'll show you the thread chart on my lathe. I didn't even stop to check that before I started, because I don't cut 27 thread per inch on my lathe. Don't think I ever have yet, so obviously I can't. I will show you guys the thread pitch chart on the lathe. So, I will zoom in here. This is where you have to go drop back 10 yards and punt. So here is the Imperial thread chart. Inch threads. 24, 26, 24. These are your different combinations where you have A, 2, or A, 2, 3, and 4, and C, and all that. And you work the gears to get your different combinations. And we go down here, 24, 26, 28. So it's 26 or 28. There's no 27. Interesting, interesting, interesting. So, I do have so I have to stop and think about this.
Now I know the old lathe that we used to have would do 27 thread per inch. But again, that was like a 1950s model, South Bend, if I remember right. This is where you stop and go, how do I solve the problem? So I'm going to dig through what I have as far as, this is where we experiment, okay? What I may do is see, okay, can I take one of those threads that does 27 threads per inch? Because I know the longer and the farther you go, they're only designed to cut so deep, but if you go too far, you can create problems. So, this is where I'm going to stop. I'm going to dig through all of my pipe dies, and I've got several. I'm going to look through, and I'm going to get everything set up. So, with the original intent of wanting to single point it, throw that out the window, go back to the hand die, the round dies, and I've got some. I'll dig through them. Again, if it were easy, everybody'd be doing it. So, and we'll figure out what that thread pitch is on that side. It looks to be the same. Don't quote me on it. Well, let's see here. Let's pull out the thread gauge here. It's a pipe thread gauge. Get the right thread gauge here. Okay, it's 1/2 inch on that side. Thread pitch is, I bet it's 27 as well too. Since it's pipe thread, it should be 27. And it is not 20, well, yeah, that's not 27. That side is. So we are half. I love these little thread gauges. These are handy. It's not 28, it's 24. Half 24. Okay, so we're half 24, which we can turn 24 threads per inch single point. We're going to do it. 27 we can't. So we are 1/8 inch pipe, 27 thread, 1/2 inch, 24. So we know we can single point the 24. I'm going to dig through everything, find out what we got going on. And for those of you that everyone always asks, because I have had people before, you can get these fancy little, there's 4 of them in a kit. Okay, they're little thread gauges. You get them from Thexton or at Napa or anywhere you get Thexton tools. I'll hold it up there. They're really, really great to have. They're really quick. Okay, there's 4 of them. You have small USS, metric, thread, large thread, and then you have pipe and spark plug metric. So there you go. More episodes to come. We'll sit down, figure it out before we start the next video. Live and unedited, that's me, guys. James Green, Short Series Shenanigans, making the brass nipple for the Marvel Schebler Carburetor. Have fun. Take care of yourself and take care of your family, because at the end of the day, your family's all you got. Get out in the garage and find out you can't single point 27 TPI in your lathe. That's a challenge. Have fun. See you in the next episode. Bye-bye.